Proof 1. Horizon. One of the most compelling arguments for a flat Earth is the appearance of the horizon. Have you ever noticed how the horizon always appears flat, no matter how far you travel? This observation contradicts the idea of a spherical Earth, where the horizon should curve away from us as we move. The reason the horizon appears flat is due to the limitations of human vision. Our eyes can only perceive a certain distance before objects start to blur and fade into the background. This phenomenon creates the illusion of a flat horizon, even though the Earth is actually curved. Proof 2. Water. Another compelling proof of flat Earth is the behavior of water. Have you ever noticed how water always seeks its own level? This simple observation suggests that large bodies of waters like oceans and lakes should also be flat and level. While it's true that water seeks its own level on a small scale, the curvature of the Earth becomes apparent over larger distances. In reality, the surface of the Earth curves gently, causing bodies of water to conform to its shape. This curvature is not readily apparent to the naked eye, but can be measured and observed using scientific methods. Proof 3. Gravity. Many people believe that gravity is the force responsible for objects falling towards the Earth. However, proponents of the flat Earth theory argue that gravity is merely a concept invented by scientists to explain away inconsistencies in the spherical Earth model. While it's true that gravity is a fundamental force that pulls objects toward the Earth's center, its effects can be observed and measured in countless experiments. From the way objects fall to the ground to the orbits of celestial bodies, gravity plays a crucial role in shaping the world around us. Denying the existence of gravity is akin to denying the fundamental laws of physics. Proof 4. Lack of curvature. Flat Earth proponents often point to the apparent lack of curvature in their surroundings as evidence of a flat Earth. They argue that if the Earth were truly spherical, we would be able to detect curvature from any vantage point. While it's true that the curvature of the Earth is not readily apparent from ground level, this is due to the vast scale of the planet. On a small scale, such as the distance we can see with our naked eyes, the curvature is virtually imperceptible. However, this curvature becomes evident when viewing large bodies of water or observing objects on the horizon from a high vantage point, such as a mountain or a tall building. Proof 5. Perspective. One of the most common arguments made by flat Earth proponents is the phenomenon of perspective. They argue that objects appear to vanish into the distance due to perspective rather than the curvature of the Earth. While perspective certainly plays a role in how we perceive distant objects, it does not account for the consistent observations made by scientists and explorers throughout history. From the way ships disappear over the horizon to the way the sun sets in the sky, these phenomena can only be explained by the curvature of the Earth. Perspective may distort our view of the world, but it cannot change the fundamental shape of the planet. Proof 6. Sunsets and sunrises. Different parts of the planet are exposed to the sun's light, creating the illusion of the sun rising and setting. Additionally, the Earth's atmosphere refracts sunlight, causing the sun to appear higher in the sky than it actually is when it's close to the horizon. This atmospheric refraction prolongs the duration of twilight, further enhancing the appearance of a sunrise or sunset. Proof 7. Star trails. Flat Earth proponents often point to star trails as evidence of a stationary Earth. They argue that if the Earth were rotating, star trails would appear curved rather than circular. The phenomenon of star trails is a result of the Earth's rotation on its axis. As the Earth spins, stars appear to move across the sky in circular paths, creating the illusion of star trails. The circular motion of star trails is consistent with the spherical shape of the Earth and its rotation. Additionally, the apparent curvature of star trails can vary depending on the observer's latitude and the location of the celestial equator. Proof 8. Flight paths. Flat Earth proponents often question the flight paths of airplanes as evidence of a flat Earth. They argue that if the Earth were truly spherical, airplanes would have to constantly adjust their altitude to account for the curvature of the Earth. The flight paths of airplanes are determined by a combination of factors, including wind patterns, air traffic control regulations, and the Earth's curvature. While it's true that airplanes do adjust their altitude during flight, these adjustments are made to maintain safe and efficient cruising altitude rather than to account for the curvature of the Earth. In reality, pilots rely on navigational instruments and flight plans to take into account the Earth's curvature to ensure accurate and efficient travel. Proof 9. Time zones. Flat Earth proponents often struggle to explain the phenomenon of time zones on a flat Earth. They argue that if the Earth were flat, everyone would experience the same time simultaneously. The existence of time zones is a direct result of the Earth's rotation on its axis. As the Earth rotates, different parts of the planet are exposed to the sun's light at different times, creating the need for standardized timekeeping systems. Time zones are established based on the lines of longitude, with each time zone representing a 1-hour difference in local time. This system allows for consistent timekeeping across the globe and ensures that people in different regions experience daylight and darkness at appropriate times. Proof 10. Lunar eclipses. Flat Earth proponents find it difficult to explain lunar eclipses within the framework of a flat Earth model. They argue that if the Earth were flat, lunar eclipses would occur more frequently and under different circumstances. Lunar eclipses occur when the Earth passes between the Sun and the Moon, casting a shadow on the lunar surface. The shape of the Earth's shadow during a lunar eclipse is curved, providing compelling evidence for the Earth's spherical shape. Additionally, the frequency and timing of lunar eclipses can be accurately predicted using astronomical calculations based on the spherical Earth model. This consistency in lunar eclipse patterns further supports the spherical Earth and debunks the notion of a flat Earth. And there you have it, 10 compelling proofs of a flat Earth debunked with simple science. While the idea of a flat Earth may seem intriguing at first glance, a closer examination reveals the overwhelming evidence supporting the spherical Earth model. So the next time you gaze out at the horizon or watch a ship disappear over the edge, remember that the Earth is not flat. It's a beautifully curved sphere floating in the vastness of space. Thanks for watching.